Hey everyone, I hope you're doing well today. In this video, I'm going to be going over all the answers and how to do each of the problems on the Unit 3 practice test. So hopefully you've given it a try at this point, and this is going to be the best thing you can use to kind of get ready and study for your Unit 3 test. Let's jump right into this first part where we're going to practice evaluating powers. So for this first example, let's take a peek at it. It says, what is the expanded form for the power 4 to the 7th power? So expanded, this is just going to be 4 times 4 times 4, that's 3 of them, that's 4 of them, that's 5, and that's 6, and then that is 7. So this is going to be the expanded form. Okay, so there's number 1. For number 2, what do we have to do? We have to find the base and the exponent and then the value for this power right over here. Okay, so the base is going to be just the number that we're multiplying over and over, so the base here is going to be 5. For the exponent is telling us how many times we're going to multiply the base together, so the exponent is going to be 3. And then for the value here is going to be 5 times 5 times 5. And so 5 times 5 is 25, and 25 times 5 is going to be 125. So that's going to be the value for this power. Okay, so let's go ahead and try number 3. So for number 3, we have a fraction here, so it's 2/3. We're going to have to raise that 2/3 to the 4th power, so it's 2/3 to the 4th power, so we'll have 4 of these. So that's 1 of them, that's 2 of them. Here's a third, 2/3, and here's a 4th one. Okay, so that just means we're multiplying 4 of these together. If you want to simplify this, you can also say, okay, well, it's really just 4 of these 2's multiplied together, and then 4 of these 3's multiplied together. Again, the top, you're just going to multiply them all together, and the bottom as well. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and on the bottom, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is going to be 81. So that would be the final answer for number 3. That's the value. Cool. Let's move on to part 2 here. So for part 2, we're going to evaluate numerical expressions. So this is where we just have to remember our order of operations. So first, we're always going to have our grouping symbols, so parentheses, brackets, all those types of things. And then second, we're going to have our exponents or indices. Anything with powers is what's going to be second. For third, we have multiplication or division, whichever one comes first from left to right. And then our last type of operations are going to be addition and subtraction. So just try to keep that in mind when you're evaluating these types of problems. We're always going to follow this order. Okay, so for the first thing for this problem, I think we're going to do division first. So if we go ahead and do that, that's going to be 23 minus, and 18 divided by 9 is 2. And so we're at 2 plus, and then I'm just going to copy the rest of this here. Then next, looks like we have multiplication is going to be the most important. So I'm just going to copy this 23 minus 2, and then 4 times 3 is 12. So just go ahead and write that. We have addition and subtraction here. Make sure we do subtraction because they're equally important. So we go left to right. 23 minus 2 is 21. So we have 21 plus 12. And then finally, we have one operation left here. So 21 plus 12 is going to equal 33. So that would be the answer right over here. Okay. Let's check out this next one, but I'm going to just kind of reuse this just so we can kind of take a peek and reference it in case we're not sure what operation to do. Okay, so let's see for number 5 here. This looks like we have a lot going on. So we want to, first off, just take a look and see that we have grouping symbols here. So we do have brackets. So we have to start by looking just inside the brackets. But even inside there, we have parentheses. So we're going to have to start with that before anything else. Okay, so let's take a look at this 6 minus 3. That's going to go before anything else. I'm just going to copy everything else. So 14 plus 3. And then we're going to leave that 14 and 3 alone for a good while here. We'll have 24 divided by 2 to the 3rd power plus 5 plus 2. So copying all of that, and then 6 minus 3 is just 3. And so this is really 2 times 3. If you want to keep the parentheses, that's fine, but it really just means multiplication here. It's not a grouping symbol. Okay. Again, we're going to keep this 14 plus 3. We can't use it until we are done with the brackets, so we're still inside here. Inside the brackets, it looks like this exponent is going to be the most important thing. So 2 to the 3rd power, that's 2 times 2, which is 4. 4 times 2 is going to be 8, so we have 24 divided by 8 plus 5 plus 2 times 3. All right, so there we have the next one. We're going to ignore this 14 plus 3. Again, that's going to stay out there for quite some time. We're not going to deal with it until we're done inside here. Inside, I think what we're going to do here is division. I think division is the most important thing. Multiplication's tied, but we have to go from left to right because they're equally important. 24 divided by 8 is 3, so we have 3 plus 5 plus 2 times 3. Okay. And then what we're going to do next is, copy this over again. And then inside, what are we going to do? We have addition, addition, and multiplication. So multiplication gets to go next. That'll be 3 plus 5 plus, and then 2 times 3 is going to be 6. So that's going to be a 6 here. And then we have this 14 plus 3 on the outside. And we have just a bunch of addition in here. I'm just going to go left to right. Obviously, you can add these together if you like, but 3 plus 5 is 8. So 8 plus 6 is what's still inside here. And I'm going to go ahead and finally find out that this is just going to be ending up with what's 6 plus 8 or 8 plus 6? That's going to be 14. So again, that's 3 times 14. So all along there was an invisible multiplication sign between this 3 and the bracket. So don't forget about that. That's a common mistake people make, because then they add 14 plus 3 by accident, but they should be doing, or you should be doing 3 times 14. So if you did that, wonderful. But 3 times 14 is 42. And then so finally 14 plus 42 should get you a final answer or value here of 56. That would be the answer to this numerical expression. Okay. Cool. Let's move on. But I'm going to use this expression again, or not expression, but the order of operations. Just keep that for reference. Sometimes it's good to just have, when you have these types of problems, just keep in mind that there's actually an invisible parentheses on the top and invisible parentheses on the bottom. So I strongly suggest you write those in. And also the fraction bar in the middle, right? This fraction bar right in the middle here really means division. Okay, so I'm just going to rewrite this so it's a little bit easier to kind of follow. So I'm going to have 80 divided by 2 to the 4th power plus 9. That's basically the numerator. And we're dividing that because fraction bar represents division here, okay? And inside the bottom, that's going to be 13 minus 2 times 3. Cool. So you can treat these two problems separately. I'm just going to kind of do the whole top and then do the whole bottom afterwards. So for the numerator, I think we have to do exponent first here. So that's going to be, let's see, 80 divided by, what's 2 to the 4th power? That's 2 times 2, which is 4. 4 times 2 is 8, and 8 times 2 is 16. So it's 80 divided by 16 plus 9. And then division is going to go before addition. So 80 divided by 16, you can do the long division or do it in your head, or you can try to see what that's equal to, but it's going to be 5. It goes in evenly. So we have 5 plus 9, and then 5 plus 9 is going to equal 14. Okay, so that's what the whole numerator is equal to. Okay, it's important to keep the whole top grouped until we have just one number. And then for the denominator, let's see what we have to do. I think multiplication is going to come first here. So we'll have 13 minus 2 times 3, which is 6. And then 13 minus 6 is equal to 7. Okay, so we really have this 14 in the top. That's this 14. And on the bottom, we have 7. And just don't forget that we have a division sign in between them. So we really have 14 divided by 7. Or if you wanted to keep it as a fraction from the beginning, that's 14 over 7. So the answer here is going to be 2. So there's a lot going on there. So I'll put that answer in a box to hopefully make it a little bit more clear. All right. That brings us on to part 3. So for part 3, let's take a look at evaluating these variable expressions, which are the same thing, just we have some unknowns. And just we have to keep in mind what each of these values of the variables are. So I'll use blue for A, I think, throughout these. And then I'll use, I don't know, yellow for blue, or yellow for B. That's not blue. And then I'll use green for C here. Okay, so anytime I see those, I'll try to use those ones to keep everything in line. So I'll try to go and use a neutral color here. So 17 for constants plus A, which we know is 4. So I'm going to substitute that in. That's going to be a 4. And then C is going to be 6. So I'm going to go ahead and let's multiply that by 6. Okay. So again, that blue one here, that was A, and then the green one here, that was C. So now it's just a numerical expression, and following the order of operations here, I'll go ahead and just say, okay, 4 times 6 is going to be more important than anything, so that's going to be 17 plus 4 times 6 is 24. And then we have one more step to do here, so 17 plus 24, I think that's going to be 41. I guess I'll start just boxing my answers now, I don't know. Didn't do it earlier, but I'll do it now. Here we have a letter A. So we have A, and then we're dividing it by B, which is yellow. So blue divided by yellow plus yellow times, what's C? C is green. Okay, so let's try to change these things out here. So we have 4, and it's going to be 4 over, what's B? B is 2/3. So B is going to be 2/3. So it's 4 over 2/3 plus B, which we said was 2/3. It's going to be 2/3 times C. Well, what is C? C is 6. Okay, so just keep in mind what this this bar or this fraction bar really means. It means division, right? That's its operation. So when we're going to go ahead and do this, this is really going to be 4 divided by 2/3. So 4 divided by 2/3. And then we're going to have to add the product of these two. So that's going to be 2/3 times 6. But we know 6 as a fraction is going to be 6 over 1. Okay, so when we're going ahead and dividing, just keep in mind that we can do keep, change, flip. So that's really going to be 4 over 1 times the reciprocal or the flipped version. So that's going to be 3 over 2. And then plus, and then we have this 2/3 times 6 over 1. So I'm trying to be very thorough here. I'm sure some of you can do this in your head, which is great. But in case this is helpful for people, I definitely want to make sure I'm being as clear as possible. So 2 and 4 can cross cancel to make 1 and 2. So if we go ahead and multiply this 2 times 3, that's going to be 6 over 1 times 1. So that's going to be 1. So it's going to be 6 over 1, or just 6 plus. And then for the second grouping, we can cross cancel and say, okay, 3 and 6 becomes 1 and 2. So if we go ahead and multiply here, this 2 times 2, that's 4 over 1 times 1, which is 1. So that's going to be 6 plus 4. And 6 plus 4 is just equal to 10. So that would be the value of this algebraic expression or variable expression given those values. For number 9, we have A, so A is going to go first here, and then plus C. C is going to be the green one I'll use, and it's divided by B. B is going to be this yellow one here. So A is 4, so I'll go ahead and substitute that, say 4 plus, and what's A? A is going to be, oh, not A, sorry, it's C. So C is going to be 6. And just keep in mind, I'm going to use this fraction bar as division just right away, so it just saves some writing later on. And then B is 2/3, so I'm going to go ahead and write 2/3 here. Okay, so let's go ahead and rewrite this division problem using keep, change, flip. So we have keep this, change this, flip this. Again, dividing is the same thing as multiplying by the reciprocal. So 6 is going to be 6 over 1. We're going to keep that. We're going to change division to multiplication. We'll flip 2 over 3. Whoops, we'll flip 2 over 3 into being 3 over 2. That's the reciprocal. Okay, so we're going to have to do multiplication first here, and I think we can cross cancel. 2 and 6, they have a common factor of 2. So that's a 1, and then that's a 3. Then multiplying 3 times 3, that's going to be 9 over 1 times 1, which is 1. So we should have 4 plus whatever this is we said was going to be 9. And then a 4 plus 9, that's going to equal 13. So that would be our final answer for number 9. Okay, for number 10, we have 10B on top of what's B. B is our yellow one, so we're going to switch that out. C is going to be green, and then A is blue. And again, we have a fraction bar, so that fraction bar means division. So I'm not going to write that extra step. So we have 18 times B. Well, what's B? B is 2/3. I'm going to go ahead and change out the B for 2 over 3. And then remember, the fractions mean the top is grouped differently from the bottom, so just go ahead and write that just in case. C is 6, so I'm going to replace C with 6. And then minus A. Well, what's A? A is 4. Just like that. Okay, so that should be how we get started. It's important that we group the top and the bottom, otherwise you might do something out of order. And so for this first grouping, what can we write this as? It's 18 over 1 times this 2 over 3. Okay, and then we can cross cancel, right? So we can cross cancel 3 divided by 3 is 1, 18 divided by 3 is 6. And then on the top, 6 times 2 is 12. Over 1 times 1 is 1, so 12 over 1 is just going to equal 12. And then for the second grouping, we can actually just do 6 minus 4, and that's going to equal 2. So it's going to be 12 divided by 2, and 12 divided by 2 is just equal to 6. So numerator was a little bit more work, but the denominator was a little bit less work. Okay, so there are the first 10 problems. Okay, so let's try one more type of problem where we're dealing with variable expressions. So we got to evaluate the following expression given the following values. So we're going to take this expression right over here, and we're going to take turns substituting in each of these. So I'll use a different color for each one, but let's start off with saying x is equal to 2. So if we were going to go ahead and do this, we would say, okay, 3, and then we're going to do times 2. We're going to substitute the 2 in here, and then plus 17 minus, and then we're changing this x to 2 as well. Okay, that's all we're doing. We're changing x to 2. This is now a numerical expression. Exponent goes first here, so we're not going to touch this one, but this is going to be 3 times 2 plus 17 minus, and then what is 2 times 2? That's going to be 4. Okay, then I think exponent is going to go, multiplication is going to go next. We already did the exponent. 3 times 2 is going to be 6, so we have 6 plus 17 minus 4. And then addition and subtraction are equally important, so we go left to right. 6 plus 17 is 23. 23 minus 4, that's going to equal 19. Okay, so that's if x was equal to 2. But let's say x is equal to 3. What would this expression be equal to? Whoops, I forgot to put the answer here. If x was 2, then the expression is equal to 19. Okay. What if x is 3? Well, let's go ahead and change it. So we have 3 times, and we're changing x to 3 now, and then plus 17, and then minus, we're changing x to 3 again here, so it's going to be 3 squared. So just like earlier, we just have a 3 instead of a 2. Exponent goes first again, so 3 squared is going to be 9, so we're going to have 3 times 3. We can swap that out for a dot because it's the same thing, and then minus 9, because 3 times 3 is 9. Then multiplication comes next. 3 times 3 is 9. 9 plus 17 minus 9. And then left to right, because they're equivalent in terms of importance, 9 plus 17 is 26. 26 minus 9, that's equal to 17. So when x is equal to 3, then this expression is equal to 17. So I'm going to go ahead and write that in. That's the value. Okay. And one more, let's pick a different color here. Let's say x is equal to 4 now. So let's do the same thing again, except now x is 4. So 3 times 4 here, and then plus 17 minus, and then we're going to take this 4 for x and square it. Follow the same steps here. 4 to the second power, that's 16 here. So it's going to be 3 times 4 plus 17 minus 16. And then using multiplication, 3 times 4 is 12, so 12 plus 17 minus 16. And then left to right, 12 plus 17 is going to be 29, so we have 29 minus 16, and 29 minus 16 should be equal to 13. So when x is 4, this expression is equal to 13. All right, cool. Moving on, let's start talking about translating some verbal expressions here. So part 4. Let's translate verbal expressions, so stuff with words, into math expressions. Okay, so important stuff to kind of dissect. There's a lot of important pieces here. So 8 less than something. So keep in mind, if we have 8 less than something, that must mean that we're going to be taking away 8 from something. So I think that's important if it helps you to box some things and kind of just like keep in mind what's going on. 8 less than something means you're taking away 8. And then the second thing that's kind of going on here is tripling a number x. So you're taking some value for x. Let me see if I can get that to work. Cool. It's being nice to me now. So tripling a number x, that's really some number x, and you're multiplying it by 3. Okay, so it's 8 less than tripling a number here. So if we triple the number, instead of writing x times 3, we really should write 3x, 3 as the coefficient, and then we're doing 8 less than it. So the minus 8 has to come afterwards. Okay, so just be careful with that. For this next part, 4 more than. Okay, that means we're adding 4 onto something else. So make sure we understand that 4 more than means we're supposed to be adding 4 to something. Okay. The next thing is, what is it 4 more than? Well, it's the quotient of y and 7 here. So this is going to be the quotient. How do we write that? Well, quotient means division, right? But how do we write division here? So we should write the quotient as y over 7 using a fraction bar. and it's 4 more than that. So we're adding 4 onto the quotient of y and 7. Okay, moving on, let's check out a couple more here. The product, okay, the product of what? The product of, let's see, product, what does product mean again? Let me see if I can get this to work. The product of, well, product means multiplication, so we're going to be multiplying something. We need to multiply something and something. Well, what are those two somethings? I know it's a little confusing. So the product of 5 and, whoops. So we're multiplying 5, and this word and is super important, right? This word and is telling us, okay, we're multiplying 5 and something else. But what is that something else? I think that something else here afterwards is going to be the quantity of 2 less than x. So what does quantity mean? This word quantity, right? That just means we're going to be putting this in parentheses. So if you ever see the word quantity, that means anything that comes after the word quantity goes into parentheses. And there's one more piece here that we want to make sure we understand. 2 less than. So if we're taking 2 less than something, that means you're having to take away 2 from something else, okay? So let's see. The product of 5, so we have this number 5, and it has to be multiplying by something. So 5 times, and then the quantity of, so we have parentheses, but what's going inside that parentheses? It's 2 less than x, so we have this x, so we don't know, and it's 2 less than it, so we have to take away 2. Instead of writing this, we should kind of simplify this down and instead go ahead and write it as 5, and then we don't need the dot. It's kind of unnecessary because we know it's implied that it's there if we don't write it. And so we really have this 5 times the quantity of 2 less than x, or x minus 2. They mean the same thing. For number 15, we have this word difference. So the difference of, so what are we finding the difference of? So what does the word difference mean? The word difference means we're subtracting some things. Okay, so it's important to know we're subtracting. So what are the two things? Let's look for the word and. The word and tells you like what two things we're going to be subtracting. So the first thing is the, looks like the product of x and 8. That's the first thing that's going to be, that we're subtracting. And what's the second thing we're subtracting? 5. Okay, so we're going to be taking, these are the two things that are going to be on either side of the subtraction sign. So the product of x and 5, well, what does product mean? Product is going to mean multiplication, so the word product means multiplication. So how do we write that? It's x times 8. X times 8, that's the product. And we're going to be taking away 5, right? So 5 here, if we do that 5, it's going to be the product of x and 8. And then we're going to be taking away 5 because it says difference. Just keep in mind, like, how can we rewrite this x times 8? Really, we should write that as 8x. That's the best way to write it. And then, again, we're taking the difference and of that and 5. So we have a product on the left of 8 times x, 8x. And then we have 5, and we're taking the difference between those two terms. Okay, so the best one you want is going to be this one for number 14. This would get full credit in terms of how you should write it as best and simplest as possible. And then for number 15, this is the best way to write this one. Okay, let's go on to part 5 here. For part 5, we're identifying each of the following for the algebraic expression. So keep in mind that terms are separated by plus signs and minus signs. So let's take a look at this first one. For this first one, what color do I want to use? I'll use purple here. So the terms, this first one is going to be 6x. That's a term. 4, that's a term. So put commas here. X, just keep in mind there's an invisible 1. So I'm going to write that right now so in case I forget it later. And then we have 8y. That's a term. And then be careful with this one. So we have this minus here. So that's actually technically a minus 2 for the term. And then this minus y means there's minus 1y for the term. So please be careful in terms of identifying the terms when there's minus signs. That's very, very important. Okay. The other thing that's really important that you might miss or you might forget is the fact that these ones are here, these invisible ones. And again, by the identity property, 1 times anything stays the same, so we typically don't see it. Let's go on to the like terms now. So which one of these are like each other? So if I kind of identify here, I think that this 6x has something like it. I think it's this 1x here. So for the like terms, let's do 6x and 1x. Okay. those are like terms with each other. What else are like each other? So let's go with the y's now. We have 8y and this minus 1y or negative 1y. So 8y, let's go ahead and write that, 8y and negative 1y. Those are like each other. And then we have some constant terms at the end here. So the constant terms, let's go ahead and box those. 4 is a constant and negative 2 is a constant. So we can go ahead and write 4 and negative 2. Those are our constant terms. Okay. For the coefficients, coefficients is just a fancy word for the numbers in front of the variables or the letters here. So we have coefficients here. Let's go ahead and see identify. So 6 right here, that's a coefficient. 1, that's a coefficient. This 8 over here, that's a coefficient. And this negative 1 or minus 1 is a coefficient, right? So we have 4 coefficients here. For the constant terms are really just going to be the numbers that don't change. So the constants are these ones here. These are the terms that will always stay the same. So 4 is a constant and this minus 2 or negative 2 is going to be a constant. For the simplified expression here, we just have to combine some things to kind of make this all look shorter, right? So if we go ahead and look at this 6x and 1x, if you combine 6x's plus 1x, that's going to be a total of 7x's, okay? And then let's see if we combine the second two. So 8y minus 1y, so don't add them because there's a minus. So what's 8 minus 1? That's going to be 7. So we're going to have 7y. And then finally we have 4, a positive 4, and then a minus 2. So what's 4 minus 2? That's going to equal 2. So again, if everything's positive, you just add like normal. But if you see stuff that has a minus sign in front of it, just make sure you subtract instead. Okay. For this last part, let's evaluate when x is 9 and y is 2. So let's go ahead and just swap these numbers out. So we have 7 times 9, and then plus 7 times 2. And then we're going to add 2. So if that's unclear, we're changing this x equals 9, so this x is going to be a 9 here. And then over here, when we said y is 2, we're changing this y equal to 2. So this became 9, this became 2. Now, just following the order of operations, we would do this multiplication first. 7 times 9 is going to be 63, plus 7 times 2. Again, parentheses means multiplication. Then multiplication comes next. I don't know why I keep trying to say exponent. 7 times 2 is 14, plus 2. And then left to right here, because it's all just addition, 63 plus 14 is going to be 77. 77 plus 2. 77 plus 2 is going to be 79. So this is just hypothetical, but again, if x was 9 and y was equal to 2, then the value of this expression is going to equal 79. Okay, let's move on to part 6. So for part 6, we're going to identify equivalent expressions with the distributive property. So there may be more than one right answer here. So let me show you the most efficient way to kind of go about solving these problems. So we need to see what's equivalent to this expression of 8 times the quantity of x plus 3. And so if we go ahead and multiply 8 times x is really 8x. Right, that's an easier way to write it. And then 8 times 3 is equal to 24. So this is, if we use the distributive property, that's what it's equal to. So based on that, we know that A is going to be one of our answers, right? Because that's literally 8x plus 24. If you're wondering if B is correct, what you can do is you can actually distribute here as well. So what's 4 times 2x? That's going to be 8x. And then what's 4 times 6 here? That's going to be 24. So look at that. It's the same thing also. It's just written using a different common factor. For C, we can check that one. So what's 2 times 4x? That's going to be 8x. And then 2 times 12, that's also 24. So far, A, B, and C are all correct. And let's see if option D is also the same thing. So for this one, we can't do any distributive property, but we can combine like terms here. So if we take this 9x and we take away this 1x, don't forget that invisible 1, 9 minus 1 is going to be 8. So that's going to be equal to 8x if you combine those like terms with each other. And then if you combine this positive 20 and positive 4, 20 plus 4 is going to equal 24. So look at that. That's actually the same thing as well. Now, if you wanted to use make up a number, you can say like x equals 2. You can do that and then test these all out as well. But the best way to kind of do this, or the quickest way, using the distributive property and using these algebraic properties and expressions, is to use the distributive property and combine like terms. So A, B, C, and D all work here. For number 18, we're taking a look at what's equivalent to this expression here. So if I were you, I would try to maybe simplify this a bit. So this is going to be a 1x. The coefficient is 1 there, and we have a coefficient of 2. So if you combine 1x and 2x, that's going to equal 3x, right? And then if you take a look at the second part here, we have a positive 5 and a positive 7. So 5 plus 7 is going to equal 12. So this is going to be 3x plus 12. That's an easier way of writing that given expression. If we take a look at A clearly doesn't work just because that says 2x plus 12, and that's just not the same thing as 3x plus 12. Okay. If you take a look at the second option here, let's use the distributive property to check. So 3 times x is going to be 3x. And then 3 times 4 is going to equal 12. So that's 3x plus 12. And that one seems to work, so that's good. And for part C, or option C, this is a 1x plus a 1x plus a 1x. So these are like terms. If we go ahead and add up this 1x plus 1x, that's 2x, 2x plus another 1x, that's going to be 3x. So x plus x is indeed 3x. And then if we add these constants of 4 plus 4 plus 4, that's going to be 12. So we have 3x plus 12. Hey, that's the same thing as what we were looking for, so that's good. And for this final one, this is just not right because 15x is not the same thing as 3x plus 12. You cannot combine those. They are unlike terms. So we just have B and C here. Okay. Cool. That's 17 and 18. Again, if you wanted to make up a hypothetical value for x, you can say like x equals 2 or higher. Just don't use 0 or 1. I'll write that here. Do not use x equals 0 or x equals 1, right? So if you wanted to use a hypothetical value, use anything that's 2 or higher. X is equal to 2 or higher. So you can make x 2 and then see which ones are the same, and that would work just fine. Okay. Let's try number 19. We're going to rewrite the expression as a product. What does product mean? Product means we're multiplying stuff. GCF, that's a vocab word, greatest common factor, and 2 relatively prime numbers or terms. So those 2 terms can't have anything in common. So very straightforward here. We have 16x plus 40. Okay. If you use the ladder method, that's a pretty nice way to do these types of problems. So 2 is a common factor here. That's going to be 8x plus 20. We could also say, what's another common factor? How about 4? And 4 goes into that 2x times, and 4 goes into 20 5 times. So at this point, if you go ahead and multiply this 2 times 4 on the side, that's going to be our GCF of these 2 terms, or these 2 values. And then what are our relatively prime terms? That's going to be 2x plus 5. So what we're going to do here is we can write 8 times the quantity of 2x plus 5. This would be the answer. Okay, so again, what's the GCF? GCF is going to be this 8 here. That's the greatest common factor. And then for the part that talks about these 2 relatively prime terms, those are these here. 2x and 5 have nothing in common. Okay. If you want to distribute this to check to see if you did it right, 8 times 2x is going to be 16x, and then 8 times 5 is going to be 40. So since that's what we had earlier, that seems to check out. Okay. Are there other ways of writing this expression not using the GCF? Sure. You could potentially use another common factor that's not the GCF, like 2, and you could have written like 2 times the quantity of 8x plus 20. You could also use 4, and 4 would be times the quantity of 4x plus 10. And technically you could use 1, but that one doesn't really help us as much, but it just lets us know that there's an invisible 1 kind of just lurking and hiding around, letting us know that it's there. So are these all options that are equivalent using distributive property? Yes, but the one that uses the GCF is the one that has the 8 on the outside. Okay, so that's the one we're looking for. Let's go on to number 20. We're going to use this following figure. We're going to go ahead and write 2 equivalent algebraic expressions that represent the area. Make sure we're doing area here of the large rectangle using the distributive property. Okay, so there's one way to do this. So the entire length of this rectangle all the way across here. So if this part is 6, right, and then this part is y, then the entire thing across is going to be 6 plus y. That's all the way across, okay? And then for the width here, we have 3. So what's one way to write the area of this rectangle? So we remember area for rectangles is going to be, right on the side here, area is equal to length times width, okay? So if we call the length here, if you say the length is equal to 6 plus y, and we say the width here is equal to 3, so then we can say the area, one expression we can write here is going to be length, which is going to be 6 plus y times the width, and we can put that 3 in front. So that's one way to write it. Another way we can write the area is, what if we don't do the whole rectangle at a time? So what if we just look at the pieces? So this part over here is just 6, and then this height here, or the width here, is going to be 3. So what's 6 times 3? We can say that's going to be 18. So this would be the area of one rectangle plus, but what's the area of the other rectangle? So the other rectangle is going to be y by 3. So if you found the area of that, that's going to be 3 times y, or 3y. Okay, so if you simplify the second one, you can say that's going to be 18. 3 times 6 is 18, and then 3 times y is going to be 3y. So these are our two equivalent expressions. So here's the first one, and here's the second one. And we know they're equivalent because we could also use the distributive property to say, okay, 3 times 6, that does equal this 18 here, right? That's that. And then 3 times y, that does equal this 3y. So that works out. Okay, so this is going to be our first expression, and here's our second expression. Okay, you could also use this simplified one here. That's probably a little better, but they're both good. Okay, for part B, we're going to go ahead and write and simplify an algebraic expression that represents the perimeter of the large rectangle. So how do you find perimeter? Well, perimeter of a rectangle is twice the length plus twice the width. Okay, so we already knew that length was 6 plus y. That's all the way across. So we're going to have the perimeter is equal to 2 times the length, which is going to be 6 plus y, plus twice the width. So the width is 3, so we're going to have 2 of these 3's here. Okay, so that's the writing the algebraic expression, but now we have to simplify it. Okay, so to simplify this, all we have to do is distribute this 2 times 6. 2 times 6 is going to equal 12. And then 2 times y is going to equal 2y, so it's going to be 12 plus 2y. And then if we multiply 2 times 3, that's going to equal 6. We have some like terms here, these constants of 12 and 6. So the perimeter here is going to be 2y plus, and then 12 plus 6 is going to be 18. Okay, so this right here would be the expression for the perimeter. And if we knew what y was, we could figure out the perimeter, but this is the expression that we would use to represent the perimeter. Okay, moving on here. For part C, it says we have to go ahead and find the area. So let's go ahead and find the area if we know that y is equal to 5. So what's the area one? Well, you can actually pick and choose which one you want to use here. So we can either use this expression from part A, because that tells you the area, or you can use this one over here. They both tell you the area. So I'm going to go ahead and choose this one. I think without the parentheses, it's a little bit easier. So I'm going to say 18 plus 3y. We knew that would tell us the area, but we know that y is equal to 5. So this y, we're changing it to a 5 here. So that's going to be 18 plus 3 times 5. So I'll go ahead and write that, 3 times 5. So then using the order of operations, 3 times 5 goes first. So that's going to be 3 times 5 is 15. And then 18 plus 15 is going to be 33. So we're going to say the area here is going to be 33 units squared. That would be the area of this rectangle if 5 was equal to y, or y was equal to 5. And this hopefully makes sense, because if you take this 5 also and you plug it in right here, that means that this entire length across is going to be 11. Like from here to here would equal 11. And then this 11 times 3 does equal 33. So you can kind of check that as well. Okay. And then finally, let's find the perimeter of this thing. So the perimeter is the outside, and that's saying if y is equal to 4. So which expression represents the perimeter? Well, that was part B. So let's go ahead and write that's 2y plus 18. That tells you the perimeter of this entire rectangle. So we're going to change y to 4 here because that's what we were given. And let's go ahead and see what that would be. So it's 2 times this 4. And then we're going to add on the 18 afterwards. And following the order of operations here, 2 times 4 is going to be 8. So that's 8 plus 18. And 8 plus 18 is going to equal 26. So if y was equal to 4, then the perimeter here would be equal 26 units all the way around. There we go. Okay, so there you have question 20. A little bit of applications for geometry here, using these algebraic expressions to represent area and perimeter. Okay, we have one final question. Question 21, we're going to go ahead. We have these different pizza prices here. So we have a small pizza. We know it's going to cost $12 each. Medium pizza, $16 each. Large pizza is $18. And then every time you choose another topping, it's $1.50 per topping. We have some different values. So W is going to represent how many small pizzas we buy. X is going to be the number of medium pizzas we buy. Y is going to be the number of large pizzas we buy. And then Z is just how many toppings you get. So what we're going to do for part A is write an algebraic expression representing the total cost of W number of pizzas. Again, that's going to be small pizzas. That's W. That's right over here. And then we have 3 large pizzas. So large pizzas, we have to make sure we use the letter Y. Okay, so the total cost, well, if we're going to be getting W small pizzas, okay, well, how much does a small pizza cost? So it's $12 for every small pizza. And we don't know how many we're getting, so we have to multiply that by W. That's how many we're buying. We don't know what that is. Plus 3 large pizzas. Well, it's $18 for every large pizza, and we know we're buying 3 of them here. So we know we're going to be multiplying by 3. So that's going to be the original algebraic expression. And what you should do here is you should condense this a little bit and write this as 12W. That's expected to write that using as short as possible. And then 18 times 3, we actually know the cost of 3 large pizzas. 18 times 3 is 54. So this would be all the work that you would need, and this would be the final algebraic expression. This would represent the total cost if we were to buy W of these small pizzas and then 3 of these large pizzas. If we knew how many small pizzas that we bought, if W was 6, then we could find the total cost. If we knew W was 1, we could know the total cost. If we knew the value of W, we could find the total cost. We just don't know what it is. And here's one final problem. I mean, maybe not scroll too far down so we can still see all the prices there. So we have to write and evaluate. So we're going to write an expression, then evaluate it. It's got to have some algebra, so some letters representing the total cost of 2 medium pizzas, and then 5 small ones, and then 4 toppings. So let's say 2 medium pizzas. So for medium pizzas, that's going to be $16 per medium pizza. The number of medium pizzas is going to be X. And then let's see, what do we have next? So we have the 2 medium pizzas. We took care of that one. What about the 5 small pizzas? Well, small pizzas are $12 each, and what variable represents them? That's going to be W, okay? And so that takes care of the small pizzas. And then we have to say, okay, 4 different toppings. So they're going to be spread out amongst those pizzas, I guess. And so that's going to be $1.50 for each of them. I'm just going to use 1.5. And for each of those small toppings, so what are the small toppings? I think that's Z. So 1.5, let me say, times Z. So that takes care of the toppings here. So this part right here is going to represent the total cost of just the 2 medium pizzas, or the number of medium pizzas. This is going to tell us the cost of the small pizzas because that has a small pizza price. And this will get the total cost of all the toppings. So that's the original algebraic expression. And we can simplify this down into 16x plus 12w plus 1.5z. So the coefficients here are 16, 12, and 1.5. All right. Now they do tell us here that there are going to be 2 of these medium pizzas. So this is going to be 2. So it's going to be 16 times 2. Okay. And then we're also told here that we're going to get 5 small pizzas. So that's going to be 12 times 5. That we're changing this W to 5. And finally, we're told that there's going to be 4 of these toppings. So 4 here, that's going to be Z. So that's going to be plus $1.50 for each of these 4 toppings. So it's a little confusing maybe to use these dots, so I'll use parentheses for multiplication, especially with this decimal over here. So if we go ahead and do this, 16 times 2, that's going to be $32 for the 2 medium pizzas. And then we're buying 5 of these small pizzas, so 5 times 12 is going to be $60 for all the small pizzas. And then finally, $1.50 each for each of these 4 toppings. $1.50 times 4 is going to be $6. If you add up the cost of the medium and the small pizzas, that's going to be $92 for the small and medium pizzas. And I'm just going to bring down this $6 for all the toppings. And then if you add up the cost of the pizzas plus the cost of the toppings, we're going to get a total cost of $98 total. That's what the cost would be for this amount of small, large pizzas, or I guess small and medium pizzas, and then 4 toppings. So there you go, these 21 different practice problems on algebraic expressions and numerical expressions. So make sure even for these application questions, you do follow through with writing this is an algebraic expression. This is the SimpLEEfied algebraic expression. When you plug in the numbers for the letters, that becomes a numerical expression, and then you just use the order of operations to solve. So hopefully you can kind of see everything tying in together a little bit. And hopefully this was helpful, and feel free to try any problems again that you need to so that you can practice and feel extra confident. So as always, keep up the great work, and I'll see you in the next one.